wherein the vice changes its angle position, whereas the blade remains the same.
Like on the x-axis?
Yeah,
you mean? Like
you can say that X for the blade remains same, the Y for the
oh,
vice
okay,
changes.
for the vice,
Yeah.
right.
In some of our machines, we do have changes where the vice remains constant, only the head changes. In this case, what you have is the head remains constant, the vice changes. So you'll have to you have slots made on the vices over here, which changes the axis direction for the workpieces. So in order for setting, let's say, setting a workpiece in 90 degrees, you can set it in angular way,
right.
Align your vices and then cut it through. The hardware features what we have is power on for my equipment, coolant, adjustment for the blade jibs, guides what we call, rollers for supporting them, the tensioning lever, model number, serial number, descriptions of the specification of the material what it can cut, hydraulic cylinder. This is actually the feeding mechanism what we use for doing the depth of feeding slowly with the help of the hydraulic feed rod for the piston assembly. For the coolant, we have filled it over here. So you have a submersible water-soluble coolant being filled up. It's been nearly filled with 10 to 15 liters of water.
It's a big tank?
Not that big, but it has to go back to the back drain where we have it, so it recirculates continuously. So you might have to have some height increment at this end.
Like
because the flooring is something tapered.
Right.
So it's top at the drain, it's high, and at the front it's low. So the coolant is actually getting accumulated over here.
So put like a little wedge or something underneath.
Yeah, at least a wedge or something to lift the height from this panel so the coolant flows back and it keeps recirculating. Or else the tank will get empty and there will be no coolant running.
The coolant, can I ask you, you said it, something about it being soluble, or is it already premixed?
It's actually premixed,
right?
water cutting soluble. This is the one what we use. You can use any water cutting liquid.
1:10, right?
This is actually 1:20. You get 1:10, 1:20, 1:30 in the market. 1 liter of water with 20 liters of, 1 liter of oil with 20 liters of water.
Did you buy that locally here?
Yeah, this is from Seashore Trading LLC.
Oh, okay, yes, Seashore.
They are actually very good, and this is used for milling, drilling, cutting, boring, every operation.
Right, okay.
This is a good one actually.
And what's the ratio? 1 to 20?
1 to 20. In UAE, we have something called Universal and AXCL. Sometimes we do get those in the Doha market, but this is Calco is a good brand here.
Yeah.
So this is around 4 liters. I've used around half a liter, nearly a liter for this unit because it's around 10-15 liters of a tank. So it's 1:15 ratio what I filled in this thing, which is good because this is mainly used for metals.
Yeah.
It's better to have more thicker compared to the thinner compositions. Coming to the operation is very easy and simple. We'll just go ahead with switch it on. You can directly use it from here or keep the cap open.
What is the other one?
This is for the coolant. So the moment when I switch it on, I have to make sure the power is on and then the coolant is on. So you will see the coolant starts pumping up and then it will rise up completely to the top. Ideally, when we are not using this equipment, we lift it to a high stop and lock it on these two slots. It's always used for transportation as well as for using it in keeping it in idle position when it's not been used. The thing when it will come down is only when we make sure that either the hydraulic cylinder knob has been released and the oil valve is open. So I can use these as a parameter to slow it down as a feeding mechanism where it will start coming down very fast or stops, or I can slowly use both of them. Either you use this or you use this. It's either way. So if I stop it with this, it stops at that position and I can slowly open it to marginally number of 1 or less than 1 and the feeding starts.
Is one like a sort of a micro adjustment or something?
It does not have any feed rate or any mechanism. It's like a hydraulic cylinder. What happens is we do have oil filled in. So the oil starts circulating and goes down where the piston pushes it inside and brings the full ram down, and then the oil recirculates back to the whole cylinder.
It's like our old one. It's just a manual feed, and you just do it gently.
Or you can lock it with this.
Just lock it there.
Lock it with these two. So what you can do is I'll keep it open, bring it with my hand, control it, and lock it and keep it there. So you can lock it here or else leave it directly to the bottom. It does not matter.
Have to cut like 60 pieces. Then I was using the machine.
You can have long rods, cut them into different pieces.
Just for me, you've got one child, and they just want a little piece of the block. I haven't even got one. I said, right, you've got to get hacksaw kind of block. You might have a project what you're doing. You pieces, that's it, so you just work. Honestly, this friction right now is just going to get really hot. The blade and the no, it's usually that viscosity of some kind of milk and stuff. But you look, there's a
What
drain,
were they using for lace also?
drain plug there. So that will now, should in theory, all drain out, go back into the
Use this knob because what happens is these three, 1, 2, 3, these three are used only when you're swapping or changing a blade. Okay, and these two are used mainly for doing different types of work. Because these two jaws they open up to 280 mm wide. Bigger than that they won't open up. So from this edge to this edge you'll be having around 280 mm what you can use. You can cut any length between that. The best thing is you'll have to keep it always close as possible. It's like the manual hacksaw where we keep the blade as tight as possible. So these two are like our tightening knobs what you can assume. So once we bring them close we tight this as well as these two. These are already preset and tensioned. These are the two rollers which pinches the blade so it makes sure that this blade is totally straight in this area. I'll show you the back part now where the blade and how it works along. Have to open this too, release them, and then these rollers they open up. This one and this one they'll open up. You can
How they will open?
you'll have to release these back screws.
The screw?
Yeah. You'll have to release these back screws and they will make sure the rollers are free. So these two has to just to be released.
Okay.
They will be opened up and then you can the blade moves in free. Release this as well. So it will slacken the belt completely. Okay, and then you can just pull it out.
that allows you to pull them out.
Yeah, that allows you to pull it out. You can also remove this. It's a cleaner what we use for cleaning the metal chips. Yeah. And while fixing back, it's the same reverse procedure. You fix it in these two rollers first, and then just nip them. Don't lock them. Just nip these. Once it sits on the complete pulley, I'll have to tight this first.
And again, is that just by feel? There's no.
There's no. I'll tell you what we do is. Guys, if we have bigger workpieces, we can adjust them, make them
Oh, yeah,
long
that's what
enough.
it was on like that, remember?
Still we can reduce it.
Yes, if
This is the minimum.
Minimum.
It's already touched the edges.
Oh, I see.
Oh, it's upstairs.
Yeah.
So then you've got that much more additional then, haven't
No,
you?
no, no.
Oh.
It's already touched this edge and this.
No, I get that. If you want to make it even bigger, that's
Yeah.
the...
Over the speed. So for changing the speeds, you have to use this lever. Different speed rates what you can use. So right now it's at the 34 meters per minute what you have. You have 34, 41, 59 and 98 meters per minute. It goes very fast when it's at the bottom pulley. We can change this by altering these two nuts over here. So first is we'll have to loosen this nut which holds the motor plate, and then loose this one which slides the whole plate mechanism. So these two are the ones will make your belt go in and out. And then it can easily be shifted to a certain, you just shift it down and push it.
On the speed it is now, how quick can you put?
Sorry?
The current speed,
It's 34 meters per minute.
yes, I understand, but what is the widest speed?
You can go any wide you want.
So that's like a general... So
That's like a too high speed is not good. It will start having friction and it will give you small bursts around. So an adequate speed of 34 or 41 is easy. 59 and 98 are too high.
We're not going to go any more than sort of, you know...
Then that's 34 is good.
Yeah.
This rod is 20.
Yeah.
So you are just going double of
But
that.
even 50, we probably... The last one...
This one, you just lose this Allen key, okay? And after that, the bottom Allen key,
Okay.
when you lose this, the plate slides in. This will act. This is like a stop lever. Okay, and this is for the plate which is holding the motor. So you just have to lose both of them. No need to remove them. Just lose them. Then the blade, this motor comes inside. It's same like the drill where you have two knobs.
Yeah.
You adjust them and they slacken, and then you change the belts and then repeat them. 4 and 41 because this is a smaller scale bandsaw equipment. If you are using very thick ones, then you'll have to go for 41, 59, 98 meter per minute. So it's like starting from 34, 41, 59 and 98. Let's say you want to cut aluminium. Aluminium is quick and good with the first two speeds, 34 and 41. For mild steel, you can also use 41 and 59, which are better. You can go with 34 because it's compatible with aluminium. So 34, 41 and 59 are much more good with mild steel. 98 can be used for brass because brass is soft. You'll have to go quickly and go at a faster rate. So you can go with 98 for the softer materials. Going faster for harder materials will snap the blade out.
Okay.
Yeah. So the faster speeds can be used for aluminium, brass, copper, such kinds of things.
Stainless steel, you have to reduce this.
You'll have to go for 34 and 41. Slow the speed.
Is this 34 now at the moment?
That's 34, the first one. 34, 41, 59 and the 98. 98 is the bottom one.
So now it's
So what you have is like you have this tank completely will filled up. Once you want to empty it, just pull it out and throw the same thing and then clean it back and refill it. It's like around. With time, this will start becoming like a, you can say like a sledge, completely thick.
Material, so if it's brass, the feed rate has to be faster. See, with that, there's
But
no
if you are
point,
using
like,
different hard grades, you will.
Just say it.
Okay, 0. Then you have 1, 2, 3, 4, 9 and 10. It's like a small knob what we use. So 1 is the first mark and then the 2. So most of the feeding what we do is between 0 to 2.
Oh, okay.
Most of them. I've never gone more than 2 or 3 sometimes in some cases. Most of them are between 0 to 2 only.
So if it's brass then, is that what you're saying? You're going no more than 2?
Yeah, you can come up to 2 because at 2 it's very fast. Let me show you.
So what would you take it to the maximum then?
From 10?
Yeah, like what?
It never goes for 10.
Oh, okay.
You see, this is the feed rate at 10.
Ah, right. Yeah,
So that's
fine.
not adequate feed rate. The reason why they give us this knob is actually a standard one. So it comes along with this pressure relief system, wherein we have this knob available in most of the markets. So 0 to 2 is the one which is used as a maximum feeding rate. So you can also use this to keep it quarter. The more you keep it open, the more it becomes very fast. So it loses its pressure.
Yeah.
So you'll have to keep that at half or less than half. So a small amount of oil is being passed in through, and then as slowly I locked it. Oh, sorry, it's the other way around. So I can lock. The thing, this mechanism actually uses this hydraulic cylinder with the oil to bring it down along with the weight of the top head to pull it along with the gravitational pull. So that's the mechanism what we use for giving it a faster.